Hi all of you, and welcome to part 2 of the kidney. So let's move on to thinking about blood supply to the kidney. How is it that all that blood is coming and being filtered? So it has a specialized arteriole, that's a little tiny artery that's arriving there, and we're going to call it the afferent arteriole. Remember, A is for arriving. So the afferent arteriole is going to feed into a region called the glomerulus, which is your filter area. And it's going to filter some of the blood, not all of it. And then that passage of blood has to continue on through and exit through the efferent arteriole. So entering afferent, exiting efferent. In the meantime, some of that blood is filtered. After it exits as an efferent arteriole, that arteriole itself is going to loop around the nephron. Now think, why do you want that little artery to be in such close proximity to the nephron? Because when you need to reabsorb or recycle some of that water that you might have filtered, that capillary is right there ready to receive that water back. Because remember, you don't want to lose too much water in the process of manufacturing urine. So in this diagram, you would have here this artery coming in, and now this is a smaller arteriole, and it's feeding in to the glomerulus here. So this would be the arriving arteriole into the glomerulus. It goes this sort of ball of yarn here of capillaries, and then it would exit through the efferent arteriole. And then notice how it's completely wrapping around the nephron, because when we're exchanging fluids and salts, they're going to be able to leave the nephron, and in close proximity, let me make this with black, we can recycle and bring things out and back into the blood if we need to. So let's label all those for you. The arriving arteriole is the afferent. It's coming into the glomerulus. It's exiting out through the efferent arteriole. And now they're going to become the peritubular capillary bed. So it's peritubular because it's around the tubules. Now notice as it surrounds the descending loop and then comes up the ascending loop here. Now some of this is the venous end of capillaries, and that is called the vasa recta. Okay, peritubular capillaries and vasa recta. Okay, so let's think about what's happening. It's a tiny bit out of focus in the renal processes. And this is a very general slide. We have the afferent arteriole arriving, all the capillaries, and what's going to happen is here, one, you have filtration. Okay, so this is like a sieve, and it's allowing fluid. Remember, this is leaky, and it's allowing fluid to exit here. And then when it exits, it gets caught in this capsule. And this capsule here is called the Bowman's capsule. So think of it out of the blood, fluid out of the blood, out of the glomerulus, landing here in the capsule. And that was the process of filtration. But now it's going to continue on, and we are going to call that filtrate. Let's see if I can write over this. So filtrate, we don't dare call it urine yet, because so much is going to happen to it before it actually gets eliminated as urine. So in here, we're imagining that this is called a filtrate. Okay, so we've filtered it, now it's called a filtrate. The other sections, the other processes that are going to happen is we can't afford to lose that much water. So some of it will be reabsorbed back into those peritubular capillaries. So it filters, 2, it reabsorbs, 3, it secretes. So here is something like, imagine some little molecule here that was traveling. And it came in here and it never got filtered. And it continued on, my little molecule, but I really need to get rid of it. It's waste. And it keeps going here, and it didn't get filtered out. And I have it here now. I can actually remove it from there. It can be secreted in this step 3 here. And even though it wasn't filtered, it will then be transported into what the filtrate is. Okay, so that's a secretion, and usually to eliminate things like urea, and we'll see about that later. And then this is going to carry on, and at the very end, it's excretion, right? Because you get rid of everything that's in that vessel, in that nephron, not vessel, nephron. So I might have just confused you. So in the yellow here is the filtrate that will become urine. And in pink or red here is all the blood and the exchanges that are happening between the blood and the urine. I've written them out for you so you can go back to your slides to study. Filtration then is fluid moving from the blood to that filtrate that's going to become urine. Reabsorption, fluid moves from the filtrate to the blood. So we're regaining that. So my little diagrams are: filtration uses a sieve because you're filtering something out, and then the reabsorption is recycling. You had it targeted for waste, but you reabsorbed it, took it back into circulation. The next are secretion. Waste moves from the blood to the filtrate without being filtered. And then excretion, elimination from the body as urine. It was once filtrate, now we're going to call it urine. Okay, those are the summary of those processes. What we want to look at next is, where do they occur? So we've stretched out the nephron here, and here's my afferent arteriole, the Bowman's capsule, and then the F here is for filtration. So we have filtration. This is the only place that filtration is happening. So we tick that one off. The second one is reabsorption. So in the proximal convoluted tubule, we have reabsorption, and that means we remove it from what is going to be the filtrate or the urine, and we're going to take it back into these little capillaries. Okay, where else does that happen? Lots of places. So look, it happens, let's see the more clear ones. In the collecting duct at the very end, it's reabsorption. In the distal convoluted tubule, in the ascending loop, and in the descending loop. So essentially you filter out a bunch of fluid with molecules in there that you might want to get rid of, and then you do a big job of recycling it back. So you use the water to eliminate waste, but bring it back in so that you don't dehydrate. Okay, reabsorption. Secretion is happening in fewer places. It's happening in the proximal tubule, in the distal tubule, and in the collecting duct. And excretion then is only happening in one place. It's only happening in the collecting duct. Okay, that's important for you to know that. So it's a good slide as a reminder. Good. Okay, so the vocabulary again: filtration means into the filtrate. Reabsorption means out of the filtrate, back into the blood. Secretion means out of the blood, into the filtrate. Remember that we're filtering blood and manufacturing urine. You can get tangled up in getting those two directions confused. So that's why I wrote it out one more time for you again. Okay, filtration, into filtrate, reabsorption, out of filtrate, secretion, into filtrate also, without being filtered. Okay, so here I just want to make sure that you understood this is afferent arteriole, and the whole sort of ball of yarn here of capillaries is what we call the glomerulus. And then the capsule just surrounds that glomerulus and sort of catches the fluid that's leaving. And then it starts the proximal tubing. Okay. When we're thinking of values, next we're going to be thinking of values. So we're going to think of, usually when you're trying to see whether the kidney function is adequate. So you're going to want to look at the amount of blood that's filtered, the amount that's reabsorbed, the amount that's secreted, and so you take some back, you remove that, minus the reabsorbed, plus the secreted is going to make the amount of solute excreted. And there's lots of studies that, this is super important, for example, when you're thinking of pharmaceuticals. So some sort of drug that you're taking, and you want to know, well, how much of it is filtered? Or does it keep circulating in the body? How much is filtered? And then, well, this particular molecule, which is the drug that you took, the pharmaceutical, is it reabsorbed? Does it go back into circulation again? And therefore the effect of it would last longer. Or does the body secrete it and dump it into the filtrate? So you want to know, when you're thinking of molecules that need to be excreted, you need to know the amount that's excreted in what amount of time, right? They tell you to take a medication every 4 to 6 hours. Why is that? Because they've studied this and they've seen what it takes to actually eliminate it from the body, taking reabsorption and secretion into account. So think of this, 20% of the plasma that enters the glomerulus is filtered into the nephron. So there's only 20% gets filtered. The rest is just going to keep going and go around the peritubular capillaries, go back into the right heart, get moved around, and maybe on the next round, a different 20% is going to get filtered out. So 20% of that plasma that enters that glomerulus is going to end up in the nephron. So how much is that in volume? Well, the kidneys filter about up to 180 liters of fluid per day. And that is going to produce 1 liter of urine. So if you're filtering 180, it means that 179 of those are going to have to be reabsorbed somehow. So think of what these kidneys are doing, the amazing job of filter, 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 take back, take back, take back. This is just to show you that the epithelium around the glomerular capillaries is modified into these podocytes, which are these cells. And so notice how this is a cell here, and it sort of wraps around these capillaries, but they have big slits in them that are going to allow that fluid to come out of the slit. Okay, so it's the actual epithelium around those capillaries that is very, very leaky, and it's made up of these cells that leave a lot of space between one cell and the next. So what we want to look at, I'm going to stop soon and leave this for the next video, is glomerular filtration rate. So GFR is your glomerular filtration rate. You want to know what the speed of that is. You want to know if you're adequately filtering. And we know that those normal values in men are about 120 to 125 mLs per minute, and in females and women about 115, making it about 160 liters a day. That means that you filter your entire 5 liters 2.5 times per hour, which is sort of incredibly remarkable, right? All your plasma is filtered 2.5 times per hour. So you can see how kidney failure is immense because you have to be filtering this blood. So can you even imagine 180 liters? You know, these are 10 liters here, but imagine a table or a floor with 180 of these liters. That's what you filter in a day. Very crazy. Okay, so we're going to stop here. We're going to begin the next video on the forces that contribute to that glomerular filtration rate. Okay, thanks for listening, guys.